بسم الله الرحمن الرحيم. We are discussing the definite integral and how to evaluate the definite integral. In some cases, when the function is given, or the graph of the function is given, and it can be converted to regular shapes, it will be useful to find the area of these regular shapes to evaluate the integral, like what we have in this example. This question says that the graph of f is shown, and we need to evaluate each integral by interpreting it in terms of areas. In the first part, which is A, we need to evaluate the definite integral 0 to 2 f of x dx. The graph of the function is given there. And we need to find this definite integral 0 to 2. If we look at the graph of the function 0 to 2 to this interval, so we'll have this shape, which is trapezoid, or I can write it as triangle and rectangle. So the shape of the function over this interval, it takes this shape. So it is I have a triangle there, we call it A1, and rectangle A2. Now the height of the rectangle as given there from the figure, this part is 1 times 2. And the height of the triangle is, because this point is 3, is equal to 2. It means that the integral of this function, which is from 0 to 2, dx equal to the area of the triangle, I will call it A1 plus A2. So we have triangle and we have rectangle. For the triangle, it is equal to 1/2 multiplied by the base multiplied by the h, the height, plus A2 is the width multiplied by length, which is equal to 1/2 now the base for the triangle, which is given by this side, is equal to 2. So it is 1/2 multiplied by 2 multiplied by the height, which is equal to 2. As I said, the height for the trapezoid is 3. This is 3. We take 1 there, so the remaining will be 2 up. For the rectangle, we have the width or the height is equal to 1 multiplied by the length, which is equal to 2. So in this case, I will have 1/2 multiplied by 2 is equal to 1 times 2 is equal to 2 plus 2 is equal to 4. So the value for this definite integral 0 to 2 of f of x equal to 4. This is the first part. For the second part, we need to find b from 0 to 5. Let me take this out. And I need to find the value of the integral between 0 and 5. Now between 0 and 5, see what do we have here? This can be as the shape from 0 to 2, and we already found this one. This part we said is equal to 4, already done. And we have, this is another shape from 2 to 3. It is rectangle. And the 3 to 5 is triangle. The height is 3. So just memorize these. So from 0 to 5, 0 to 5 f of x. We can say it is A1 plus A2 plus A3. I have three areas. The first one was trapezoid, and we already found it in the part B or part A. This is A1. A2, it is rectangle. That is 1 and multiplied by 3, the height. And A3 is triangle. What is the opposite? Again, go back. A1 is given by this part. A2 is this triangle or rectangle. And A3 is this triangle. I have three areas. That is A1 plus A2 plus A3. Now A1, we already found it from the first part, is equal to 4. Plus A2, it is the width, 1 multiplied by 3. So it is 1 multiplied by 3 plus A3, which is triangle. It is 1/2 multiplied by the base. The base for this one, which is from 3 to 5, is equal to 2. That is 1/2 multiplied by 2 multiplied by the height, which is equal to 3. So the value for this one will be 4 plus 3 plus 2 is cancelled with 2 plus 3. So it is equal to 10. So the value for this definite integral is equal to 10. For the next one, see, I need to find 0 from 5 to 7. Let me remove everything there. From 5 to 7, this point, and this is 7. I have triangle. The height for this one is 3, and the base is 2. But this area is under the x-axis, which means that the value for this definite integral will be negative. So in this case, from 7 to 5, so it's given from 7 to 5, not 5 to 7. It is reverse. 5 to 7, let's see. 7 to 5. Come back to see it again. So it is 5 to 7, not 7 to, it is from 5 to 7. 5 to 7, f of x dx is equal to minus the area, because it is under the x-axis, so it must be negative value, which is equal to minus the area is given by 1/2 multiplied by the base, which was 2, multiplied by the height, which is 3. This is equal to minus 3. So the value for this definite integral is equal to minus 3 because the curve is under the x-axis. For the next one, from 3 to 7. Just take this picture again. Put it down. Now I need to solve D, which is from 3 to 7. From 3 to 7, this is 3. So I'd have this area. That will be triangle. And this area, which is another triangle. And this is 5. So it means that I need to find the two areas. From 3 to 7, f of x dx is equal to a1 minus a2, because one of them is positive above the x-axis, which is positive, and the second one is under the x-axis, which is negative. So this will give me 1/2 multiplied by the base for a1, which is equal to 2. It is 2 multiplied by the height, which is equal to 3, minus, now the second one is 1/2 multiplied by the base, 2, times the height, 3. So the answer will be 0 in this case. And we will see this in the coming section. We call this the net value of the integral, or the net integral of the function. We are adding the positive with the negative, or subtracting with the area under the x-axis. We call it the net value of the different integral. It's like we're having two forces, one in the positive direction and one in the negative direction. Then it will be 0 if they are equal in the magnitude. Next one, E. For E, we have absolute value 3 to 7. Dx. Now, if we have absolute value, it means the negative part will be up. It will go in the positive direction. Because of the absolute value, we don't have any negative. So it is not negative anymore. Between 0 and between 3 and 7, both of them will be positive. In this case, we are adding, not subtracting. So I will have a1 plus a2. That will be 1/2 multiplied by 2 by 3 plus, because of the absolute value is always positive, so we are not subtracting. Multiplied by 2 times 3, this will give me 6. So the value of this absolute value function is equal to 6. So we have to be careful about the function and its absolute value. If we have absolute value, then we don't have any negative value for the integration. All of it will be positive. If it is just without absolute value, I will find the positive part, negative part, then we subtract. For the last one, from 2 to 0. What we found in part A was from 0 to 2. If we reverse the limit, then also we multiply the value of the different integral by negative. This is one of the properties for the definite integral. This part is F. The definite integral 0 or 2 to 0 f of x dx is equal to the negative of the definite integral from 0 to 2. If we reverse the order, we multiply the function by negative, or the integral by negative. Reversing the limit means multiply the integration by negative. So this will give me minus the area of that question. And the area, we found it in the part A as 4. So this one will give me minus 4, which is equal to minus 4. So this is the idea of finding the definite integral by interpreting the curve under the function into regular shapes. If I have regular shapes, we can find the value of the definite integral. But if it is not, or the shapes are not regular, then we cannot do it. We have to do it in a different way.